Hello. I did an experiment some time ago to measure the rate of evaporation of water in a petri dish that's 9.1 centimeters in diameter and 4.55 centimeters in radius. Um, so we have water on the surface, and we want to determine answer the following question. How many molecules of water leave each square centimeter of surface per second? This was done at about 24 degrees Celsius. And I put the petri dish on a balance and measured mass versus time. And here are the data. And it's in time is in minutes. And I then plotted the data. Of course, you can see that the mass is decreasing, and that decrease is due to evaporation. And I made a pretty straight line, as you would expect, because the surface has the same area over time, and the temperature was room temperature, so it was constant. So it's just decreasing at a constant rate. The equation for that linear equation is mass equals minus 0.0055 times time plus 16.098. Now, the slope minus 0.0055 would be the rate of evaporation in grams per minute. So the rate of evaporation, I made it positive, but it's actually negative, 0.0055 grams per minute. I'm getting that from the slope. That's how fast water is leaving the surface. The rate of evaporation in grams per second would be, this is a good example of doing conversion, 0.0055 grams per minute times 1 minute over 60 seconds, which is 0.000092 grams per second. I'm going to do everything in 2 sig figs because I think my slope is good to about 2 sig figs. Now, if I want to get the rate of evaporation in moles per second, I'm going to take the grams per second and convert that from grams per second to moles by multiplying by 1 mole. For water, it's 18.02 grams per mole. And I get 5.1 times 10 to the minus 6 moles per second. Moles of water are leaving the surface of this petri dish here every second. Now, if I want to get it in molecules, I have to change from moles per second to molecules. And so I take the moles per second and multiply by Avogadro's number, which is the number of molecules per mole. And that's 3.1 times 10 to the minus 18 molecules per second. Now I want to get the rate of evaporation per square centimeter. So I have to find the area. Pi r squared is a formula for a circle. Pi times 4.55 squared is 65.0 square centimeters. So if I take the rate of evaporation in molecules per second and divide by the square centimeters, I'll get 4.8 times 10 to the 16 molecules per second per square centimeter of surface. So that's a big number. All right, it's a big number. You could say it's 4,800 trillion molecules per second per square centimeter. So this is a nice little problem that students could do. And you might ask some other questions after they've done the problem as a discussion. We're using water as the liquid here. And water, it's fairly volatile, but if we did methyl alcohol or ethyl alcohol, how do you think the results would compare? Okay. Ethyl and methyl alcohol have a lower boiling point than water. They're more volatile. If you put your finger in ethanol, and you feel it very, very cold as it evaporates off your finger, much more than water. How would the values change if you change the temperature? This was done at about 24 degrees Celsius. And questions like that could be pretty interesting for the students to ponder. Okay, so I hope you enjoyed that video, and I'll see you next time.